You may need to watch this video more than once. It is your job to make sure you understand what I am teaching you. We are continuing with quadrilaterals, and the quadrilateral that I want to tackle now is the trapezium. Now the trapezium has an interesting structure. It either looks like a roof of a house, or it could look like a boat. It could also look like this with a straightish side there. Okay, so trapezium has got one pair of parallel sides. It's characteristic, one pair of opposite parallel sides. The symbol that we use for parallel is a little arrow. So that side and that side are not parallel. They may not be the same length either. This side and this side are definitely not the same length. However, this line and this line are, the top line and the bottom line are equal distance away from each other. So that line, the top line and the bottom line, are parallel to one another. This is the symbol for parallel. It is an arrow. If we look at the boat shape, the sides are not parallel and they are not equal. And the top and the bottom, they are not equal in length either. However, they are equal distance apart, which means that they are parallel. The sides of this shape are definitely not equal in length, and neither are they parallel. The top and the bottom are not equal in length, but they are parallel to one another. They are equal distance apart. That is the characteristic that we can use when we are dealing with a trapezium. The last shape is called a kite. You will be familiar with this shape. A kite. And I'm going to draw a framework just to help me get the sides right. So it looks like a cross, and I can draw in the top two lines and the bottom two lines. Then I'm going to go over these lines, dotted lines, to make them solid. And these lines are the diagonals. So the green lines, I'm going to write it over here, are diagonals. They move from one corner to the opposite corner, diagonals. And interesting about these diagonals is that they cut each other at 90 degrees. Isn't that interesting? So we end up with 1, 2, 3, 4 90 degrees triangles. Now the other thing that these diagonals do is when they cross over, they bisect the shortest diagonal. So it means that this side is equal to that side. So let's write that in. These are the characteristics of the kite. The diagonals intersect at 90 degrees. Second point, the shortest or the shorter diagonal is bisected. Now bisected means two. Okay, so it's cut into two when there is an intersection, and so that is in two equal parts. Another word that means that in two equal parts is equidistant. In two equal parts. Now the kite is interesting to me because there seems to be a shorter section on top and a longer section on the bottom. And this line here is the same length as this line here. And this long line is the same length as this long line here. So we can say of a kite that the adjacent pairs of sides are equal in length. Adjacent pairs of sides are equal in length. Now, what does adjacent mean? Well, adjacent means next to. So you can see that this line is next to that line. They're not opposite. It's not those two that are equal. It is the lines that are adjacent. So adjacent is a very fancy word for next to. A very fancy word for next to. The kite has an interesting brother, and that brother is called the arrowhead. So I'm going to write it here. The arrow head. And it looks just like an arrowhead. So it looks like that. And then it's almost as though this end has been squashed in. Just like an arrowhead. And the diagonals obviously don't apply here because it's been squashed. The diagonals have no weight in this arrowhead, but that side and that side are equal. And this side and this side are equal. That comes to the end of our quadrilaterals. The kite has a lot of information around it, and it would be advisable for you to learn it off by heart. The arrowhead is an interesting spin-off of the kite. And then, of course, we have the trapezium.